Hello students, and welcome again to my channel. My name is Mr. Meshak Ngigi and welcome to eMaths with Meshak Ngigi. Today we're going to be checking something called complex variables and particularly on transformation. And in this particular video, we're going to be checking on inversion. Kindly, if you have not checked videos on analytic functions, harmonic functions, and how to get complex conjugates to make a function to be analytic, kindly follow the videos that are in the playlist called complex variables. All right, now in this particular video, as we check now types of transformation, we start with what we call inversion and we check an example. These are from NEC past paper, so kindly follow along. So the question says, determine the image of the circle z, the absolute of z plus 2j equals to 3 in the w plane under the transformation w equals to 1 over z. So as you can see, this is an inversion, 1 over a complex function. Then we say this one is an inversion. So solution. So the first step is always to get the equation of the original circle. Okay, so the equation of the original circle, we say, is given by z, plus 2j absolute gives us 3. So what is the absolute? How do you get the equation of a circle? It is always, how do you get the absolute of a function, or how do you get the absolute of this particular function? So first of all, we change our z to be in terms of x and y. So we'll have, and we just first of all write it in that way, yj plus 2j absolute equals to 3. Then take the real and imaginary parts together. So the real part here is only x, because this one has a j, this one has a j. So we put that together, y plus 2, then we put a j, then equals to 3. Then the absolute means we take the real part square, the imaginary part square, then we get the square root of it. Okay, so this means x squared plus y plus 2 into bracket squared, then you get the square root. That should give us what? That should give us 3. So at any point, even if you had the other questions when you only have a z, okay, those are simple questions. So we have a z equals to 3, for example. So that will just mean x plus yj absolute, then you take x squared plus y squared equals to whatever you have on the right hand side. Then from there you just expand the same way we're just doing it here. So now expanding this, we'll have the square root of, expanding the part here, so we have x squared plus, so expanding this term, we shall have the first term squared plus twice the first and the second. So what is the multiple of y and 2? It is 2y, then twice of it, that gives us 4y. Then the second term squared, which just gives us 4, right, equals to 3. So we are saying the expansion of this term is always the first term squared twice the first and the second. So the first and the second, if you multiply, it gives you 2y, then twice of it, now it gives us 4y, then the second term squared gives us that. Now from there, we want to get rid of the square root, so you square both sides. So you shall have x squared plus y squared plus 4y plus 4, all right? Then the other side you shall have what? You shall have 9. Therefore you can bring the 9 on this other side, so you shall have, your equation will be x squared plus y squared plus 4y. Then 4, when 9 comes to the left hand side, it becomes negative. So 4 minus 9, that will give us negative 5 equals to 0. Okay, so this is the equation of the original circle, but remember, it's supposed to get the image of it. Now, so we work out the transformation, that is the inverse. So we know, what do we say about inverse? So if we have w equals to 1 over z, interchange the value of the w and z, so this comes here, this comes here, so we have z equals to 1 over w. But what is z and what is w? Z is given by x plus y j, right, together. Then remember, since this one is an image, it is still a complex number, but given in terms of u and v. So it is u plus v, u plus vj. Then again, you should not have a complex number in the denominator. So what do? Multiply by the conjugate of whatever you have in the denominator. So multiply by u minus vj. So you can see the conjugate is just given by changing the sign. So this one is positive, then you have the negative, and whatever you do in the denominator, you also do it in the numerator, and the other way around. So you multiply by that. Now what will be the outcome of this? You know, so you're just multiplying this times 1. So in the numerator you shall have u minus vj. In the denominator, you know what will you have? It is always, when you multiply a complex number times its conjugate, it gives you the first term squared plus the second term squared. Okay, so it is u squared plus v squared. If you follow the video on complex numbers, you'll really understand why we have a positive here and not a negative. So therefore, now you have x plus yj is given by u minus vj over u squared plus v squared. Now remember, we have two terms in the numerator. We have the u and we have the vj. So we can split them into two so that we can compare. Remember here, what you're supposed to be doing is making x the subject of the formula and y the subject of the formula. Then the x and y are replaced in this particular equation so that you can get the image that has been found by this particular transformation. So therefore, split it into real and imaginary. So our real part is u, then over u squared plus v squared. Our imaginary part is minus v over u squared plus v squared. Then you have your j. So therefore, compare the real part on this side and the imaginary part on the other side. So the real and the real, the imaginary and the imaginary. So our real is x, our real is this. So our x value therefore will be given by u over u squared plus v squared. Then our y is the imaginary part on this other side. So our y now will be given by negative v, right? U squared plus v squared, neglecting the what? The j. You neglect the j on this side and the j on this side because we are just doing a comparison. So whatever is real here is real here. Whatever is imaginary here is also imaginary there. Then the last step now is to replace. You replace or substitute x and y in the equation of the circle. The equation of the circle. Together, so just replace it in this particular equation. So you can do that here. There you can put there here, so that you can have just another line there. So now replacing x and y here. So we know of let me just rewrite it here: x squared plus y squared plus 4y minus 5 equals to 0. Okay, so now what is your x? Your x is given by this. So we have u over u squared plus v squared into bracket squared, then plus y squared minus v over x squared u squared plus v squared into bracket, then you square, plus 4, then y is minus v over u squared plus v squared. Okay, then minus 5, that should give you what? Should give you 0. Now square, remember a square applies to everything inside a bracket. Okay, so therefore we shall have u squared, then u squared plus v squared into bracket squared, then plus, when you square negative v gives you a positive of v squared. So again u squared plus v squared into bracket squared, then you shall have minus 4v, okay, all over u squared plus v squared. Okay, then minus 5, this one is positive. No, it is not positive because you have a negative, so it will become negative, so equals to 0. Now you can put all these under the same denominator, because you can see we have u squared, v squared, u squared, v squared, u squared, v squared. So what we can do here, we can multiply everything with the LCM of all this term, because this one is 5 over 1. All right, this one is 5 over 1. So we can see our u squared plus v squared has been repeated all through, but the highest of them is the one that has a what? Has a square. So we can say we multiply all through by the LCM, and the least common multiple here of these, and this will just be the one that has the highest power. So therefore, if you multiply this term, if you multiply u squared v squared times the same value, so the LCM is this: u squared plus v squared, then into bracket squared, so multiply through by u squared plus v squared into bracket squared, because this is the LCM. Are you together? This is the LCM of that. So for the first part, you just remain with what? U squared. For the second part, because the LCM is just the same, so this term and whatever you shall multiply with shall cancel out. This and the u squared v squared shall also cancel out. So again you shall have v squared, then minus 4v. So you multiply it with the square of it. So at the upper side you shall just remain with u squared plus v squared, then minus 5 into bracket u squared plus v squared, then squared, equals to what? Equals to 0. So kindly note, we have multiplied by the denominator. So the denominator you multiply by itself, so this and this cancels. The denominator again multiply by itself, it cancels. You remain with u squared, here you remain with v squared. Then here we have the denominator, which is squared. The term here is squared, but the term here is 2 power 1. So one of them cancels, so you just remain with one of it. But for 5, since you don't have u squared and v squared, when you multiply with it, you have that term. Now the essence of this is so that we can have a term such as this. You can see now all through. So taking u squared and v squared as one term, you take it as one term, you realize that in each and every term we have a u squared plus v squared. Okay, so for every term we can now say divide. Remember, we want to eliminate a possible place where we shall have a u squared v squared with another square. Okay, so we take this term and this term, and when you're expanding functions which are either inversion or any other transformation, and you have a you'll always have a place where you have a u squared and a v squared. All right, so now divide all through by u squared plus v squared. So if you divide this term by u squared v squared, the first term, now let me just put it here so that we really understand what we are doing. So we have that term, we divide it by u squared plus v squared. Then you come to the second term, 4v u squared plus v squared into bracket, then divide also that with u squared plus v squared. Then you come to minus 5, again divide it v squared into bracket squared, divide it by u squared plus v squared, then equals to 0. 0 divided by any term just becomes 0. So we notice this term and this term cancels. We remain with what? 1 minus this term and this term cancels for v. Now you have one of it here and we have a square, so 1 cancels with that. So you have negative 5, then u squared plus v squared equals to 0. Now you can multiply all through by a negative so that you can remove the negative that we have before the u squared v squared. So multiplying all through by negative, multiply by a negative value, multiply by negative all through. So this term becomes, so you can just rearrange. We shall have 5 u squared plus v squared. Then this one becomes positive also, plus 4v, but our 1 becomes negative 1 equals to 0. Again, by working, we know one thing. So we can divide all through by 5 so that we remove the constant that that is appearing at u squared and v squared. Remember, we're supposed to get something nearly the same, such as this. All right. So we shall have u squared plus v squared plus, remember, you're dividing by 5 all through, so 4 over 5v, then minus 1 over 5 equals to 0. So therefore, this is the equation of the image. All right, this gives you the equation of the image. Now, what if you're told to find the center and the radius to that particular equation? So you're told to find the radius and the center of that particular equation. So we know the formula of getting the general formula of a circle. I'll start in regards with what? In regards to x and y. So it is given by x squared. So we shall have x squared plus y squared plus 2gx plus 2fy plus c equals to 0. So that is the general way of writing an equation of a circle. This is an equation of a circle not at center 0, 0. Remember, the equation of a circle at center 0, 0 is given by x squared plus y squared equals to r squared. Okay? So therefore, now, just because we have this can be used to get the center and the radius for this. But now, since we have an image which is now in terms of u and v, your x becomes your u and your y becomes your v. So we can just change this part and we have u squared plus v squared plus 2gu plus 2fv plus c equals to 0. Right, together. So this is just another way of writing the equation of the circle, but now in regards to the image. So how do you get the center? So the center, the formula of a center will be given by negative g negative of f. Then what about the radius? The radius will be given by the square root of g squared plus f squared minus c. Are we together? So the task here is just to find your g and your f. Now, just come to the equation. How do you get your 2g? How do you get your g and your f? So you come at where you have your g, which is with respect to u variable, and compare it with what you have in the function. So I'll just write it here. So it is u squared plus v squared minus 4 over 5v, then minus 1 over 5 equals to what? Equals to 0. So now I compare. We have a u squared, v squared. So 2gu, do we have a u variable? No. So therefore, your 2g is 0. Therefore, your g is 0. There is no u variable without a square. Then you come to the second, 2f. Now we know our 2f should compare to what we have in v. So what do we have at v? It is 2f, the 2f here compares with this value. So negative 4 over 5, right? So multiply by 1 over 2 both sides by 1 over 2. So f value, so this and this goes, we have f equals to by 2, 1 by 2, 2. So we have negative 2 over what? Negative 2 over 5. So therefore, your center will be given by, so it is given by negative g, negative f. So our g is 0. So either positive or negative, it is just 0. Then negative f. So if f is this, the negative of it will be 2 over 5. So that is your center. Then radius is given by square root of. So what is your g? Your g is 0. squared. What is your f? Negative 2 over 5 squared minus our constant c. What is our constant here? Negative 1 over 5. So it is minus 1 over 5. So which one gives us? Positive 1 over, gives us positive 1 over 5. So you can get your calculator and we check that. So we have 2 over 5 squared plus 1 over 5 plus 1 over 5, okay? Okay, let me bracket these first. 2 over 5 into bracket, then square, and plus 1 over 5. So you get your answer is 9 over 25. 9 over 25, and the square root of this basically is 3 over 5. So radius is 3 over 5. And that, students, is how you determine the image of a circle in a complex variable, and also determine the center and the what? Determine the center and the radius.